Friends of Chemistry. I'm here doing the On Your Own 11.4 and 11.5 on page 367. So 11.4 says, the following reaction is carried out in laboratory. 5H2O2 aqueous plus 2KMnO4 aqueous plus 3H2SO4 aqueous yields 5O2 gas plus 2MnSO4 aqueous plus K2SO4 aqueous plus, can you please stop shaking the table? Thank you. Plus 8H2O liquid. Really. If 125 milliliters of 0.5 molarity H2O2 is reacted with an excess of the other reactants, how many grams of oxygen will be produced? So in order to do this problem, we need to understand our conversion units. It's just like in Module 1. Module 1, we talked about conversion. This equals this. So how do we get from this to that? We can do a conversion. Okay. This is stoichiometry. Stoichiometry is the fancy word for, in chemistry, using the chemical equation to figure out how much of the different things we have by using the correct conversion units. Okay. If we look at the chemical equation written out there for us, we see that for every 5 moles of H2O2, we produce 5 moles of O2, which is oxygen. So in other words, it's a 1-to-1 ratio. 5 to 5 is the same as 1 to 1. Okay? So for every mole of this, there will be a mole of that. For every 10th mole of this, there will be a 10th of a mole of that. For every 900 moles of this, there will be 900 moles of that. So we can use that information to figure out the grams of oxygen. So what we're going to do is we're going to remember the molarity equation. The molarity equation is number of moles per number of liters. Okay? And what do we know? We know the number of liters and we know the molarity. So we can figure out how many moles of the H2O2 are used. Once we figure that out, we can figure out how many moles of the O2 are formed. And then we can figure out how many grams. So here we go. So the molarity, okay, so we want to find the number of moles. Let's perform a little algebra here. We're going to say number of moles is going to be equal to the molarity times the number of liters. So we know the molarity. It's 0.5 molarity. It doesn't really have units, so I'm not going to really, or it would be moles per liter. Now, it's going to tell us moles at the end of it, but number of liters, so it's 125 milliliters. Okay, and we know that for every 1 liter, there are 1,000 milliliters. So we divide this by 1,000. 1, 2, 3. So 0.125 liters. Okay, so we're going to work with liters because that's the way our molarity is set up. It's not set up with milliliters. It's set up with liters. So times 0.125 liters. Before I perform this math, I want us to see how many significant digits are we going to report in our answer. This has 1. This has 3. We're going to report 1 significant digit in the answer to this. So I'm going to multiply this by 0.5. One, 2, 3, 4. 1, 2, 3, 4. I'm going to say 1 significant digit equals 0.06, and this is moles, right? Okay, so this is how many moles of H2O2. I use 0.06 moles. So looking back at my equation, I can see I'm going to use the same number of moles, or I'm going to yield, I'm going to yield the same number of moles of oxygen. So it's going to be 0.06 moles. Now, we can use our knowledge to figure out how many grams of oxygen that will be, because we know that for every 1 mole of O2, it's going to be how many grams? Well, O2, we're going to look at oxygen here in the periodic table. We see that it's 16.0 atomic mass units, okay? And so 16.0 plus 16.0, or 16.0 times 2, we get 32.0. 32.0. That means that for every mole of oxygen, it's 32.0 grams, okay? I can set up my conversion. I can either say 1 mole per 32.0 grams, or I can say 32.0 grams per 1 mole. I hope you can see all this. I think you can. Which one am I going to use? Well, I have 0.06 moles of oxygen, and I want to find out how many grams. So the conversion unit I'm going to use is this one, because it will cancel out the moles and give me the grams, times 32.0 grams per 1 mole. Moles cancel. I'm going to be left with grams. I'm going to multiply. You certainly can use a calculator. I'm going to do it here in my pretty little head. I'm working and I'm making a video. I'd prefer not to have you shout at me at this moment in time. Thank you so much. And I have 1, 2, 3, 1, 2, 3. Okay, how many significant digits do I have in my factors? I have 1, I have 3. I can have 1 in my answer. So I'm going to say that is 2. 2 grams. 2 grams. Okay? So 2 grams is the answer to 11.4. You will produce 2 grams of oxygen. Okay. I'm going to pause this here and do a separate video for 11.5.